Hi, today we are going to see about audio system in consumer electronics. Outline of this topic. An essential part of any loudspeaker system is the enclosure in which the loudspeaker is to be used, often called a baffle. Most of baffles today are built into more or less complex box-like structures. Hence, baffles and enclosures are used interchangeably. The sound coming from the loudspeaker is routed into certain paths and prevented from going into other paths by blank walls put in its way. Thus, baffle connects routing the sound energy. The cone of a loudspeaker moves as a unit. When the cone moves forward, the air in front is compressed and the air in the back of the cone is rarefied. The sound released from the rear of the cone is of opposite phase to that released from the front of the cone. If the sound from the rear is allowed to flow so that it meets the sound from the front, cancellation takes place and the response of the speaker drops off sharply. Such an arrangement is called an acoustic doublet, in which the two sides of the diaphragm are represented by a negative and a positive pole radiating respectively. If these doublet sources are closer together, it is obvious that the negative wave will be cancelled by the positive wave at almost all points in space. This is the true, however, if the poles of the doublet are so close that their spacing is only a small fraction of the length of the radiated wave. This condition is readily recognized in any speaker when tested on a workbench without benefits of any baffle unit. The edges of the cone can be extended with some rigid flat material so that it is necessary for sound waves from the rear to travel out to the edges of the material before they can meet the sound wave from the front and interfere with them. The added material is called a baffle. With the speaker alone, the front and rear waves must travel along one side of the cone to meet at the edge. This path is so short that a speaker alone without baffle will usually not reproduce much below 350 Hz. Baffles should be made of good sound insulating material and should be soft enough to prevent rattling. Soft woods are satisfactory, but a material like cellotex is more appropriate. The speaker must be securely fastened to the baffle and the baffle must be rigidly mounted to prevent rattling. If a bubble is to be if a baffle is to be of limited size, the speaker should not be mounted in the center. The center is a bad position because the path lengths of all four edges are the same and the frequency components on one side at which the path length is one wavelength are severely attenuated. If the speaker is moved towards one corner, the uniformity of response is much better because of the path length to the each edge is different and the interference attenuation is distributed. The interference does not have to take place around the edge of the baffle but sometimes is deliberately made to take place throughout a port. The figure shows the baffle eliminates doublet action by increasing back to front wave path length by one half length. Mounting a speaker on a flat baffle is shown in this figure. An infinite baffle or an approximation of it is one of the best speaker mountings. However, its size is a disadvantage in an ordinary home. Because of the size problem, various arrangements have been developed in an attempt to get the same effect without the use of so much space. This has led to the design of speaker enclosure. A true infinite baffle completely eliminates doublet action. The complete absence of doublet operation will ensure that the low frequency response obtained will be limited not only by the baffle but by the low frequency capabilities of the loudspeaker used in the installation. The simple flat baffle is shown to reduce the maximum dimension of the baffle. The outer portion can be bent back at the four edges to form an open box. The open back cabinet arrangement is one of commonly employed for radio and television receivers. The low frequency response is lacking in this type arrangement. The small speaker used under the cabinet are limiting factors. The open box speaker has yet another disadvantage. Any sudden sound peaks of any frequency or sounds of low frequency can excite the box into oscillation at the resonant frequency. As soon as the box is closed, the air in it is no longer free to move in the open as in the open back cabinet. Evolution from a flat baffle to a simple enclosure. The mass of the cone, the compliance of the cone suspension, and the compliance of the air in the box are all effectively in series with each other. An important feature of the closed box is the fact that because there is no motion of air in and out of it, there is no inertance or inductive effect. There is only compliance or capacitive effect. Generally, a closed box of a given volume will raise the resonant frequency of the system by a given percentage above the resonant frequency of the speaker. In the infinite baffle enclosure, all radiation from the rear of the speaker is eliminated. This minimizes interference but also makes systems of this type less efficient than other which utilize the sound from the rear. Equivalent circuit of closed box enclosure is shown in this figure. Even speakers of the same model are seldom exactly alike because of tolerance in manufacture. These tolerances are actually an advantage because the difference in the resonant frequencies of the respective speakers tends to distribute the speaker resonance effect and make low frequency response more uniform. Thank you.